All right, ready? This is 11. So the good, like I said, the good news is that some of this overlaps with what we've talked about. Like you have a little bit of a foundation built. There are some differences. Okay, so especially in like the next section, there's a little differences. But first of all, when we used limit notation this year, we used limit notation to describe the end behavior. We used limit notation to describe like the right and left-hand approach to certain things. This is a little bit different because you're actually talking about the limit. So some of it overlaps. Like the limit as you approach a hole is the y coordinate of the hole. That is the same. But when you talk about something where a limit is doing the end behavior or a limit is shooting up to positive infinity, we would have said the f of x equals infinity there, and that is not a limit. The limit of that graph actually doesn't exist because it goes to positive infinity. So if you like think of Lindsay Lohan when she says like the limit does not exist, right, in Mean Girls, today's the day that happens, okay? So the notation you are familiar with, that's the good news. It says if f of x becomes arbitrarily close to a unique number L as x approaches c from either side, then the limit of f of x as it approaches L is written as this. Limit as x approaches c, which again, this is where we're used to, f of x equals L. So we will give the value there. A lot of times it would just say like limit as x approaches, I don't know, like 2 is 1/2. Like literally you're just giving the value as it's approaching it. Okay, and there are, the first way we're going to do it is, again, something you're used to, which is that chart. So we're going to fill in our chart. Hopefully we know how to do this pretty well. I would recommend typing this in as your y1 and then taking and plugging these each individually in. Or you could use the value on your graph. That's the fastest way to do it. You obviously could also do 3 times 1.9 minus 1, and then 3 times 1.199 minus 1. You could go all the way through. But because you're comfortable with it, I would say the fastest way is probably to type that in as your y1. So 3x minus 1 is your y1. And then you can make the y1 of 1.9, and I get 4.7. And then the y1 of 1.99, and I get 4.97, and the y1 of 1.999, and I get 4.997, and the y1 of 2, which is 5, and the y1 of 2.001, 5.003, and the y of 2.01, 5.03, and the y of 2.1, 5.3. Now it says use this table to estimate the limit. So the goal here is to find the limit. So what's happening as my x value is approaching 2? What happens to the y value? It goes specifically to where? 5. So 5 is the limit of this function as x approaches 2. And then it says use the graph to confirm the answer. So if I wanted to graph this, y equals 3x minus 1 is what kind of graph? A line. How do I graph the line? So start at -1, use my slope up 1, 2, 3 into the right one, or down 1, 2, 3 into the left one. If I go up 3 into the right one more time, I get that point. And then we're just confirming what would happen to our graph. Ooh, I moved it too far. We're confirming what would happen to our graph as our x approaches 2. So as our x approaches 2, that coordinate point that we found, the y value is 5. So the limit fails to exist if one of these 3 things happens, okay? So the first is if the f of x or the graph approaches a different number from the right side of C and then from the left side of C. So this could happen like in a piecewise function situation, okay? Where if I had a graph and I wanted to know what was happening at 2, and I had one side of my piecewise function that looked like this and one side that looked like this. If I asked you what was the limit as it approaches 2, there are two different values, right? If one is up here and one is here. Whether that's an open dot or not, it doesn't matter. If they are approaching different values, that is a situation in which I would say the limit does not exist, okay? So if it is approaching two different values from the left and the right, I literally say limit does not exist on web assignment. That is DNE. Number 2 says that it increases or decreases without bound. So if you're talking about something that has a vertical asymptote, it would increase or decrease without bound. So what we used to say here is that the graph is going to positive infinity, right? Which is right, the graph is going to positive infinity. So if I wanted to know what was the limit as it approaches 0, okay, that is going to positive infinity. And that is how I would describe the graph, but the limit doesn't exist. The limit is where does it stop, and it won't. So the limit here would it doesn't exist. Whether it's unbounded up or unbounded down or both up or both down, it doesn't matter. If one part of your graph as it approaches that x approaches value is unbounded, then we would say the limit does not exist. And then the last kind is if it oscillates between two fixed values. And this looks weird. Like if you see this on a graph, it almost looks like a squished sine curve or cosine curve. It would do something like this. And it could go in different directions on both sides. But if I asked you what was the limit as it's approaching 0, it's oscillating up and down so fast that it's alternating between two values, you wouldn't be able to determine it. So if it looks like that, we would also say the limit does not exist, okay? So if it's moving up and down, almost like a sinusoidal curve, quickly, and it's squished like that around wherever you're looking, then we would say the limit does not exist. Now, that's not to say that, like, on the outside of this, we can't have a limit. Let's say I went to 3. There would be a limit there because they would both be approaching the same value. It's just that it's around the asymptote where it is unbounded, where it does not exist. Does that make sense? Yeah?
So
Okay.
If it says as x approaches infinity, there's also no limit, right?
So now we're going to use, that's not even in this section. That's your end behavior. That's the next section. No, that's 11.3. So that's when we use it for end, that's 11.4. No, it's 11.3. That's when we use it to describe the end behavior. Yeah, which is not this, that it won't even happen in this section. All of these limits are going to be toward a number.
Okay.
Not towards infinity or negative infinity. That section will be the easiest for you because it's all based on your horizontal asymptote. You already know all that stuff. Yeah. All right, so example 2 says show that the limit does not exist and use the graphing utility to verify. So we're actually going to use the graphing utility to graph these and then look at the graphs. So if I wanted to graph this f of x, I go to y equals, remember your absolute values under your math menu. So I have to go to math, and then I go over to NUM, and that's where ABS is. That's where absolute value is. So I go y equals, I go to math. I go over to NUM, I grab absolute value, I put my x in.
See, we can
He
get
actually
it,
doesn't exist.
we can get it faster than Maid if he's not here.
Yeah.
So you say we type the absolute value of x and we put the bottom one to the...
Yeah, you want to type that whole thing in here, so you'll see what mine looks like.
It's an odd graph.
It is. Well, it's a piecewise function, right? Everything to the right is going to have one value, and it's always going to be positive, and everything to the left is going to have one value.
Is me graphing it like just showing that it doesn't exist, or do I have to like?
It will say, if it says explain why, you got to use the words.
It says show that the limit doesn't exist.
Yes.
Then use a graphing utility.
Yeah, I know. We just use the graphing utility to do it. If you wanted to plug in points, that would be the other way. You would see as it approaches 0 what happens, and they would always be two different values. So this was what I typed in. This is what I got. And as I'm looking at 0, which is here, notice it's approaching from two different values. So that was, wait, let me line it up. That's when I would say the limit does not exist. Because it's two different values, okay? If it asks you to do this without a graphing utility, so does not exist. If it asks you to do this without a graphing utility, I'd have to plug in values. So I'd plug in values before 0 from the left. So 0 would be at the middle, and I would say, like, maybe I'm going to plug in -1, -2. The closer I get to 0, so if I did like a -0.9, -0.09, as I get closer, the more accurate it's going to be. And then I would plug in like 1 and 2, and you would see that these values would all be at 1, like this. And these values would all be at -1. So as you approached 1, they would be different, which leads you to does not exist. All right, let's try to do B without a graphing utility. What does this graph look like? Fresh off your AP.
It's got a vertical asymptote at 1.
It's got a vertical asymptote at 1. Does it have a horizontal asymptote?
It does not. It may have a horizontal.
How do I know if it has a horizontal asymptote?
It has one at 0.
Oh yeah, this is my rapid review video.
It has one at 0 because the exponent in the top would be 0, which is less than, right? So it's there. So what's going to happen as it approaches 1? My graph is either going to look like this, or it's going to look like this and this. What happens as it gets closer to 1?
It's going to go in different directions.
It's going to go in different directions, and it's going to be unbounded, yes? Because that asymptote makes it turn.
So look at these.
So this also does not exist. And if it asks why, it's because your graph is unbounded as it approaches 1.
Is it gonna ask why on the quiz?
No.
Okay.
Actually, I didn't make yours yet. So I don't know the answer
Just
to that.
throw it in there for extra credit.
Maybe. I'll let you know before you take it. Yeah. To verify this, you would see it go like this and like this. Okay? And again, we would know there's a vertical asymptote. It's at, not there. At 1. At 1. So it'd be there and there. All right. Example 3 says use the graph to find the limit. So I gave the equation and I gave the graph, but really, I'll explain why in a second. If you had the full graph and you could read your coordinate points, you wouldn't need the equation. So if I had just given you this graph, first of all, what value of x am I looking at? At 1, right? I want to know what's happening at 1. So I go to where x is 1 and I find what?
Then it's approaching 2.
2, good. Would be the y coordinate of your graph. So your limit is 2.
Is that how
If,
oh, sorry.
no, go ahead.
I'm sorry. Is that how you, like, if we had to answer the question, do we have to put f of x equals 2?
You could literally just say 2. What is the limit? Is 2. Let's say that graph wasn't an exact point, which is the backup is your equation. Let's say it was somewhere here and I wanted to know where that exact value is, then I would just take my 1 and I would plug it in here. So 1 minus 1 squared plus 2 gives me 0 squared plus 2, which is 2. So you can use either one for most scenarios, okay? The graph, obviously, if it's a clear point. The equation, if it doesn't become undefined, which is what we're going to get into. That process is called direct substitution. It will literally say, find the limit using direct substitution. You take the value, you plug it in, okay? But that doesn't work every time, which is what we'll talk about.
What
Yeah.
What if it's something like the piecewise function on the slide before? You can't plug it in there.
You could, yeah, we put like the absolute value of x over x.
Yeah, but if
So if it was 1, you'd be able to find it.
yeah, but
If it was 0, you wouldn't. Huh?
isn't the answer D and E though? Like if I plug in, like it asks you for the limit of 0.
Because it asked for the limit of 0, this would be undefined.
Oh, so then you know it's D and E.
Not necessarily. That's where the catch happens.
Oh, okay.
Yep. Yeah, we'll get to. All right, so this one, find the graph, or find the limit using the graph. What's happening as I approach -3? This is -1, this is -2, this is -3. What's happening? No solution. Does not exist. D&E does not exist. The full words are does not exist. Why doesn't exist? It's unbounded. Good so far. All right, now we're gonna do the direct substitution. So this does not work every time because if it's undefined, you have to find it a different way, which we'll get to a second method in a second. But the easiest way to find it if you're given an equation is simply plug it in. Whatever value x is approaching, you will plug in to the equation that is next to it, and the y that you get is your limit. So it will look like this. Find the limit using direct substitution. For a, I'm literally going to take -1 and plug it in. So -1 to the third minus 3 times -1 plus 7. -1 plus 3 plus 7. 2 plus 7, which is 9. So the limit as x approaches -1 is 9. Easy stuff. Yes?
Isn't it the same as like how we did before? So would it be like limit as x approaches -1, f of x is equal to 9?
You would just say equals 9. Not f of x. Okay, B, the limit as x approaches pi of tan of x. If I plug pi in there, I get tangent of pi. What is the tangent at pi? Good. And C, the limit as x approaches e of 6 ln of x. So 6 ln of e is what? 6. So that is direct substitution, which if it works is the easiest way to do it. Still good. Okay, here's properties of limits. So this I feel like you should be okay on this because this is like using our notation as far as functions go. In the scenario where you're using your property of limits, it doesn't always give you the original function. What it will say is the limit as f of x or as x approaches c, and it will literally give you c so you don't know a value, is, and it will give you the number there. So it could say like the limit as it approaches c, f of x is 3, for example. And then it would say the limit as x approaches c, g of x equals 10, for example, okay? And then it could ask you to do all these different things with those limits. A scalar multiple would say something like the limit as x approaches c of 2f of x. What do you normally do if there's a scalar multiple on the front? You multiply it. So you literally take 2 and you'd multiply it times whatever they give you for the f of x, which in this case was c, which in this case was 3, and the answer would be 6. Then you could do a sum or difference. So it could say the limit as x approaches c of f of x plus g of x. Now this doesn't mean you're adding f of x and g of x. It means you're adding their limits. What was the limit in this example of f of x? 3. The limit of g of x? 10. So 3 plus 10 would give you 13. It could ask you to multiply the 2 together. So I'd get 3 times 10, which is 30. It could ask you to divide the 2, f of x over g of x in this case would be 3/10. And it could ask you to raise it to a power. So it could say f of x to the second, which in this case would be 9. So you're just performing whatever those operations are on the limits. If you had to first find the limit, that might happen. You have to find the limit and then perform the operation. Or it literally will give you the limit and you perform the operation. See if you could do them. All right, so if the limit of f of x as it approaches c of f of x is 5 and g of x is 7, what would be negative 3 f of x would be? Negative 3 times 5, negative 15. Okay, f of x, the limit of them, f of x plus g of x would be 5 plus 7, 12. And g of x over 4 times f of x, g of x is 7. 4 times 5, 7/20. Easy stuff, yes? Good? Questions? Yeah, that's it.